So what we have is this circuit, and these are the values we need to solve for. So I started with when time was less than 0, which is when the switch is closed, and we can modify the circuit like this, because when the switch is closed, that means that the capacitor is open. So the circuit is to a direct circuit. So this is how it's modified, and then these are in parallel. So you can do Req is equal to 12 times 4, 12 plus 4, which is equal to, I got my calculator, hold on. That's equal to 3 ohms. So we can simplify this like this. And then with this, you can use voltage division to find VC at 0 by doing that is equal to the voltage, which is 24, times the one across, 3 ohms over them added, so 3 plus 6, which is equal to 8 volts. And then you can find WC of the capacitor, because that has an equation of 1/2 times capacitor times voltage squared at 0, which here you can see is 1/2. C is 1/6. You can, oh, did I not write that down? My bad. This is 1/6 F. Sorry for not writing that down in the beginning. So C is, that's 1/6 times VC of 0 squared, which is 8 volts, so 8 squared, which is equal to 5.33 joules. And then we can take T is greater than 0, which is when the switch is open and the circuit is modified. But for it to be useful, you'd use the right side of the circuit, not the left side, because the left side is kind of useless to us. So you do 1/6 divided by 6F VC of T. This would be 12 ohms and 4 ohms. You can see that these are in parallel, which we already did before, and we know that that is the Req, that is equal to 3 ohms. So you can simplify that. Hold on, let me move my calculator over there. It's getting in the way. Okay, and then we can do this. We can do VC of T like this. And then we can solve for the time constant using this. Tau is equal to R times C. We know that R is 3 ohms and C is 1/6. So we get the time constant is 1/2 seconds. And then you can solve for voltage, which we know that VC of T is equal to, at 0, e to the negative t over the time constant tau. And we already know these except for t, so we can set that equal to the 8 that we got before, e to negative t over, and we know that tau is 1/2, so over 1/2. So that means that this is equal to 8e to the negative 2t volts. There we go.